Remember, when we're solving an inequality, it works just like equations. We still do things to both sides. The only thing to watch out for is if you multiply or divide by a negative. Anyway, so what I'm going to do is I see 7a on the right and 2a on the left, which means I like to have my variables where it's biggest. So I'm going to subtract 2a from both sides. If I want the variable on the right, that means I want to get rid of this minus 15 there, which means I'm going to add 15 to both sides. This will cancel off, that's why I did it. This will cancel off, that's why I did it. I'm going to wind up with 10 is less than 5a. Dividing both sides by 5, 2 is less than a. I typically want to write the variable on the left in this case, so I'm going to write a is greater than 2. If I were doing this on the number line, with that being 0, it would look something like this with an open circle and the arrow going to the right. This next one has a fraction in it, and the fraction has, or the denominator has, a negative value. That's really important. So I'm going to multiply both sides by -3. Now this is where alarm bells go off, sirens wail. If we multiply both sides by a negative number, the sign switches. And again, going from here to here, I multiplied by -3. That's a problem. Now we are going to add 4 to both sides. Watch your integers. And I'm going to write x is greater than or equal to -11. And I could graph this. It would look pretty much like the one above it, except it would be a closed circle because it's greater than or equal to. Now this looks a little bit different because we have 2 inequality signs. Well, that's okay. It doesn't make it any harder. Now, instead of doing the same thing to 2 sides, we actually do the same thing to 3 parts. And it works exactly like before. I see this -4 there. I'm going to add 4 to that, and to that, and to that. Now I have 0 is less than 2x is less than 14. Well, I want to get rid of this 2 like I would if I was doing an equation. I'm going to divide everything by 2, and I'm going to wind up with 0 is less than x is less than 7. And I'm done. If I wanted to graph this, 1, 2, 3, 4, 5, 6, 7, I could have an open circle there, an open circle there, and then go in between. Now this one, I showed one of these in the previous slide, or one of the previous slides. When you have absolute value, there are a couple different ways of dealing with this. If it was simply absolute value of x less than or equal to 3, it would look something like this. It would go between -3 and +3. That's what it would look like. However, this is x minus 1. The absolute value of x minus 1 is less than or equal to 3. If you know anything about graphing, you might recognize that x minus 1 represents a shift to the right of 1 unit. And what that's going to do, instead of going from -3 to +3, like I just had, I should write that back down, I guess. If I take this solution and move it to the right 1 unit, I'm going to wind up with, I'm going to put an arrow down to this, I'm going to wind up from -2 to +4. Again, that's if you know a little bit about how graphing works and the fact that this x minus 1 really means 1 to the right. I'm gonna actually do how to do this sort of out fully. Remember what absolute value does? Absolute value, if x minus 1 is positive, then basically the absolute value signs drop off. And then let's add 1 to both sides. The other half is when the x minus 1 is negative. And what absolute value does, if it's negative, you put a negative in front to make it positive. Well, now we have to get rid of this negative sign. So let's divide both sides by -1. And when you divide or multiply by a negative, we switch the sign. Alarms go off and that sort of thing. Now I'll add 1 to both sides. So I wind up with x being bigger than -2 and less than +4, which goes back up to here. That's what I drew a minute ago. And how I'm going to write this is -2 is less than or equal to x is less than or equal to 4. And we're done.